Assalamualaikum and hi everyone. It's me again, Shaiful from UMP. Today we're going to continue our lesson for BL1233 Analog Electronics on fixed bias configuration. I hope you already watched my previous presentation on emitter bias configuration. Okay, let's start to recall what's in our syllabus. So now we are in the third chapter, which is BJT amplifier in 3.3, which is BJT bias circuit. In BJT bias circuit, we're going to focus on fixed bias configuration for today. Okay, the learning outcome for this subchapter is you're able to identify the KVL loop and also able to analyze the network. And the second learning outcome is able to draw and design the load line.
Okay, on your left, this is your fixed bias configuration network, and then on your right, this is the emitter bias configuration. We can compare these two configurations. I can say the difference is only at the RE here, or we can assume that RE equal to 0 ohm. Actually, for this analysis, you can just substitute the value of RE with the value of 0, and then you will find the value of the IB and also all the equations. Okay, before you can proceed, let me explain about the equivalent circuits. Okay, same as emitter bias configurations, you can split VCC into two sources, which is that's connect to the RB. So here is positive terminal, and then the minus terminal will connect to the ground. So let's label this one as a VCC, and then from here we will connect to another VCC, positive, negative, and positive negative terminal, and then connect to the ground. The value is same VCC. Okay, this is the full equivalent circuit for fixed bias configurations. So on your right, we have base emitter loop, or we can call this one as a BE loop, and then on your right we have the collector emitter loop, or we can call this one as a CE loop. For the KVL, we can do for the BE loop first to find the value of IB, IC, and also IE. Okay, as I mentioned just now, actually we can just substitute the value of RE here with the 0 value, but maybe we can try the KVL first. Let's say we use the clockwise loop. So we will start with the minus VCC for the KVL, and then the current flow is IB, so IB times RB, and then we have the voltage drop at the transistor, which is BE junction. So we note this one as a VBE, the value is 0.7, and then this is the complete loop, it should be equal to 0. So your IB will be equal to BCC minus VBB, and then over RB. Okay, if you look the emitter bias configurations, so if you substitute the value RE equal to 0, so we will get the same equation as this one. Okay, and then for the IC, we can just simply use the equation, which is IC equal to beta IB, and also the IE, we can use equation of beta plus 1 times with IB. Okay, so this is the KVL on BE loop. Okay, for the KVL on CE loop. Okay, we will use clockwise. So we'll start with the VCC first. So we have the positive VCC here, and then we have the voltage drop at the VCE, or we can say this one the voltage drop at between collector and emitter terminal, and then we have the voltage drop at the RC. So this is the complete load. This one should be equal to 0, and then we have to rearrange the equation to find the value of VCE. So VCE equal to VCC minus IC RC. So if we can compare the KVL for the fixed bias configuration and emitter bias configuration, the difference is only this one, which is the value of IERE. For the fixed bias configurations, we have no RE, meaning that the value of RE equal to 0. That's why you will get this equation without IERE. Okay, and then let's say we have to find the value of VC. So we have to know where is the VC. So here is the VC with positive terminal here, and this is the minus terminal here. Let me draw the arrow of voltage. So this is your VC. So in this case, you can do the KVL. I think you can refer to my previous slide. So in this case, you will find the VC is equal to VCE, or another way to find the VC is you do the KVL, and then you will find the value of VC will equal to VCC minus IC RC. Okay, please try by your own to prove this equation. To draw the load line analysis, we need two information, which is we need the IC saturation, and also we need the VCE during the cutoff. So we have to use the KVL on CE loop. For the IC saturations, the information we have is VCE equal to 0. But forgot to mention, let's say this is the first point we have to find. So during the IC saturation, VCE equal to 0, so we just substitute the value into these equations. So you will find the value will be, the equation will be VCC equal plus IC RC, and then plus 0 equal to 0. So IC saturations is equal to VCC over RC. And then for the second point, we need to know the value of VCE. Okay, when the VCE cut off, the information we have is IC equal to 0 milliampere. So if you substitute the value into the KVL, so you will find the value of VCC plus 0 plus VCE equal to 0. So you will find the value of VCE equal to VCC. So to draw the line, so this is the first point. So IC saturation, you have to find out the value. The value here is VCC over RC. Okay, let me write here VCC over RC, and then you have another point here, which is the value is VCC. So just connect these 2 points using a line. So this line we call it as a load line analysis.